Hello everybody. Welcome to this video tutorial for Ansys Discovery. In this tutorial, we're going to walk through a basic structural simulation problem. If this is your first time using Ansys Discovery, I suggest you walk through the videos on the welcome screen to get familiar with the UI, navigation, selection, different tools, the help menu, and so on. Otherwise, click here to open the home page. To import a geometry file, click Browse, Open Geometry File. Navigate to the appropriate folder, select the geometry file you want to use, and click Open. Okay, this is the geometry that we're going to be using in this simulation. Now we're going to focus on the white valve body in the middle of this geometry. To do that, select any face, right-click, and indicate that you want to solve physics on this selection only. You can also right-click and hide all other bodies. Please note that on the left in the model tree, you have icons which show you which bodies are hidden and not participating in the simulation. Okay, let's go ahead and apply some physics inputs. There's a couple of ways to do that. The first way is let's select this face and then click here to expose the halo. The halo is a place where you have access to the most common tools that you're going to use. So let's go to the Structural Tools category and select Support. This launches the heads-up display. And let's apply a fixed support by clicking the green check mark. You'll notice on the left in the physics tree, the fixed support that you just created shows up. To dismiss the heads-up display or HUD, hit Escape 2 times. Now, there's another way to do the same thing. You can choose to activate the HUD by clicking on the Structural Physics category icon in the ribbon. This activates the head-up display as you see. And then you can choose the geometry and apply the appropriate physics input. And you'll see on the physics tree on the left, you have the second fixed support showing up. So let's hit Escape 2 times again to dismiss the HUD. Okay, now what we want to do is select all the faces on the inside of this valve. So how do you do that? That can be quite tricky. Well, we have some very advanced selection tools that you can use, and you can access those by clicking here to expose the halo. You'll notice that we have, in addition to the physics tools, we have selection tools, geometry editing tools, and so on. So let's click on the selection tools, and let's use the Select Using Boundary tool. Now this launches the HUD as before, and I want to remind you that at any time, if you're not sure what these icons do, you can click F1. And this is a very nice way for you to get help with the various tools that you might need to use. Hit F1 again to escape the overlay help system. Okay, to select all the internal boundaries, what we're going to do is select this face, and this face. We're going to click this icon to select the seed face and just click any interior face. And you see it has automatically picked all the interior faces. Now you can click here to expose the halo again, go to the physics tool category, and then select the pressure tool. And then once again, I want to remind you, if you hit F1, it tells you what all these icons mean, and it even shows you little movies on how to use many of these icons or tools. Let's hit F1 again to exit. Now let's apply a pressure of 1000 psi. So just type in the number 1000. You'll notice that the default units are pascals. You can click here to use a different unit. So let's choose psi. Now I just want you to notice that the heads-up display turns green when you have successfully provided all the inputs you need for that particular tool. So double escape again to exit. Now you'll notice on the bottom, you have the SID or Simulation Information Display. This is where a lot of information and messaging related to the simulation shows up. Once again, hover over there, click F1, and it tells you what these icons mean. But essentially, it is indicating that you are working on a structural simulation based on the physics inputs that you've applied. So let's review all the inputs. So this is the default structural steel. Gravity appears on the tree but is not included by default. We have a fixed support in that location, another fixed support in this location, and we have a pressure of about 1000 psi on the internal faces. So we're ready to go. All you have to do is click Solve. You'll notice that we are in the Explore mode by default, indicated in the orange icon at the bottom. In the Explore mode, we are using our real-time GPU solvers to give you very quick directional guidance as to what's going on with this particular design or simulation. So you see in just a few seconds, we have a result. By default, the results shown are displacement or deformation. You can change that to stress by clicking here and choosing 1 μc stress. Now you'll notice the stress hotspots. You can turn on a cut plane by clicking here. And you might need to rotate the model to get a proper view. And you can also identify max stress locations by clicking on this gear symbol and clicking this icon to show min-max locations. So as you might expect, we have a max stress area right here where you have a very sharp radius all around. So let's turn off the cut plane. So we've identified where our max stresses are. Now, I want to point out on the top right, we have an icon which indicates the different basic engineering values that you might be interested in. So things like factor of safety, maximum displacement, von Mises stress, and so on. So let's take a look at the max stress. So this chart shows you the max stress that has been predicted for this particular simulation using the GPU solver. Now let's make a small design change. To do that, I recommend you pause the simulation and turn off the results. So let's zoom in and let's select this face. Let's move it down a little bit. Now let's click here to activate the halo, and let's go to the geometry editing tools. And let's choose the pull tool. Now just click and drag to expand that radius or increase that radius a little bit. We're just doing this to get an understanding or confirmation that increasing the radius will indeed reduce the stress in that area. So once you're done, hit Escape 2 times. Now I want to point out that you can certainly make this design change in your favorite CAD tool, re-import the geometry, and rerun the simulation, but I just wanted to show you how easy it is to do those simple operations right inside Ansys Discovery. Now that we're done, click Solve again. In a few seconds, you'll have your updated results. There we go. If I click on the max von Mises stress chart, in a few seconds, you'll notice a chart updating. And you can indeed get confirmation that the stress in that location, or the max stress, has indeed gone down based on my design change of increasing that radius. So there you have it. This is your basic structural simulation, part 1, using the real-time GPU solver in Ansys Discovery. Please watch part 2 of this tutorial video, where I will go into the Analyze mode and perform a high-fidelity, high-accuracy simulation where I apply local mesh controls and use our traditional CPU-based Ansys solvers to give you a much more precise and high-accuracy result for this simulation. Thank you very much, and we'll see you at part 2 of this video tutorial.